right, we're going to determine whether these are a factor of the polynomial. We're just going to use synthetic division really quick. So remember, if it says x minus 3, we're going to put a positive 3 over here because the 0 would be 3. We're testing if that's a 0. So we have 1x squared, 2x, negative 3. We bring down the first digit. 3 times 1 gives you 3. 2 plus 3 is 5. 3 times 5 is 15. Negative 3 plus 15 is 12. So it didn't work out to 0, so that is not a factor. Nope. So here we have x plus 4, so we will try negative 4. We have 2x to the 4th, 8x to the 3rd, 0x to the 2nd, 2x, and 8. Bring down our 2. Negative 4 times 2 is negative 8. 8 minus 8 is 0. Negative 4 times 0 is 0, plus 0 is 0. Negative 4 times 0 is 0, plus 2 is 2. And negative 4 times 2 is negative 8, plus 8 is 0. Great, there's no remainder. That means, yes, it is a 0. So we got 2 more to try here. These ones are in theory for you to try if you're in class. X plus 2, so we'll do negative 2. 4x to the 2nd, negative 2x, positive 5. Negative 2 times 4 is negative 8. This gives us negative 10 times negative 2 is positive 20. So this would give us 25. Nope. Now on this one, remember, it has to just be x. So we need to divide everything by 3. So I'm just going to rewrite that real quick. It'll be x minus 2. And then p of x, it'll be x to the 4th minus 2x to the 3rd, 2x to the 2nd, 1x, and minus 10. So we'll test that out. Positive 2, 1, negative 2, 2, 1, negative 10. 2 times 1 is 2. This gives us 0. 2 times 0 is 0. Plus 2 is 2. 2 times 2 is 4. Plus 1 is 5. 2 times 5 is 10. Plus negative 10 is 0. So yes, that would be a 0. Cool. Review some factoring. Remember, on these trinomials, you want to check the last number. They're multiplying to negative 15, so it's got to be one of each. They add up to negative 2, so they're 2 apart, which would be 3 and 5. So we'd have x minus 5 and x plus 3. Here, our leading coefficient's negative, so we have to factor that out. They also have a common factor of 3x squared. So if we factor negative 3x squared, we're left with x squared minus 10x plus 25, which that's a perfect square trinomial. 5 squared is 25, 5 plus 5 is 10. So it'd be x minus 5 squared. Here we have the difference of squares. You square root them, put one with a plus, one with a minus. 4x plus 9, 4x minus 9. So a lot of old stuff coming back here. Now remember, it has to be subtraction between them for them to be factorable. So there's no such thing as the sum of squares. So that one is not factorable. Here they have an x squared in common, which would leave us with 8x minus 1. You can't go any further with that. Here, factors of 20 that add up to negative 9 would be negative 5 and negative 4. All right, factors of 16 that add up to negative 8 would be negative 4 and negative 4, which we would just write as x minus 4 squared. Here they have a 2p in common, which would leave us with p minus 5. That's it. That's our greatest common factor. Here our greatest common factor is 2x, which will leave us with x squared minus x minus 90. Factors of 90 that are 1 apart would be 9 and 10. So it has to be a negative 10 and a positive 9. So there are 6 here. 9 to try out. So I'll write them quickly, but you should be trying these to review your factoring stuff. So here we'd have an x in common, which would leave us with x squared minus 49. And that's a difference of squares. would be x plus 7, x minus 7. Here, x minus 6, x minus 3. 2 times negative 2 is negative 4, so they need to be 3 apart, which would be 4 and 1. But remember, with these, you have to try to divide it by that number in front. So 4 over 2 is 2. And then here you can't do anything, so you kick the 2 to the front. 2x minus 1. Extend that page. 28, x plus 7 and x minus 4. Here they have a 3x in common, x squared plus 3x minus 4. And that would be x plus 4, x minus 1. We have a 4x in common, x minus 6. Difference of squares, 5v plus 3, 5v minus 3. Perfect square, a plus 5 squared. And kick out our negative 3, leaves us with x squared plus 8x minus 16, plus 16, sorry. And then that is a perfect square trinomial, which would give us x plus 4 squared. Great. Factoring by grouping. When there are 4 terms like this, you just split it down the middle and factor each half. So here, if we take the greatest common factor on the left, they have an x squared in common, which would leave us with x plus 3. On the right side, our leading coefficient is negative, so we have to take out a negative. They also have 4 as a common factor, which would leave us with x plus 3 over here. Now you will see they both have the x plus 3 in parentheses, so that'll go in one of our parentheses. The other will be this x squared minus 4. Now, they love throwing this at you. Check for, are there any difference of squares, which we have right there. So the x plus 3 can stay, but x squared minus 4 would factor to x plus 2 times x minus 2. Be careful of that. That's what they're going to try to throw at you at the end. So here if we split it, which we should always look for a greatest common factor first, but there wasn't any. So left side we have x squared, x minus 1. Here we kick out the negative 25, which leaves us with x minus 1. All right, so outside we have x squared minus 25, which is going to be that difference of squares. So we'll have to do one more step on this one. And then we also have the x minus 1 that they have in common. So x squared minus 25 would give you that x plus 5, x minus 5, and then we also have that x minus 1. That would be our final factored answer. So there are 2 for you to try here. Try them out. I'm going to go over them right now. Split it. X squared, x minus 2, minus 9, x minus 2, x squared minus 9. It's a difference of squares again, which will give us x plus 3 and x minus 3. We also have the x minus 2. Over here, split it, x squared, 2x plus 1. These have 4 in common, 2x plus 1. So we have x squared plus 4, which we're not going to be able to do anything else with that because that's the sum of squares. And we have 2x plus 4. Nice. All right, last thing is perfect cubes. So the sum or difference of 2 cubes. So look at the rules up here. If you have 2 things that are perfect cubes, meaning you multiply them by itself 3 times, and you have it. So like 8 is a common one because it's 2 times 2 times 2. Or 27 is 3 times 3 times 3. So anything you can multiply by itself 3 times would be a perfect cube. Yeah. So when we're taking this back into factoring it, you'll notice our first set of parentheses shares the same symbol that our cubes have. So if it's plus in between those 2 cubes, then the first parentheses will be just plus. Then it alternates for the first one in the second parentheses, And the last one, regardless, is always plus. So let's try one out. Always look for a greatest common factor. So these have 5x in common, which leaves us with x cubed plus 8. Now, x cubed is a perfect cube because it's x times x times x. So if we're looking at the formula here, it's like our a is 1, or sorry, x, and then our b, 8 is 2 times 2 times 2, so it's like our b is 2. So look at the rule up here. It says first you just do a plus b. So a would be x, right, the cube root of x to the third, plus b would be the cube root of 8, which is 2. Okay, the last set of parentheses, you do a squared, so x times x is x squared. You change the symbol, so if it was plus, you make it minus. You multiply them together for the middle one. See how it says ab in the formula? So x times 2 is 2x. You always put plus, and then you square the last term. 2 squared is 4. I swear if you multiply these out, you come up with 5x to the 4th plus 40x. It's actually pretty remarkable. So this would be our final answer. Let's try it again. Any common factor? No. But these are both perfect cubes. 2y to the third power would be 8y cubed, right? 2y times 2y times 2y would give you 8y to the third power. So that would be our a, 2y. Keep the symbol. 27 is 3 to the third power. So it would be 2y minus 3 for the first set. Second set of parentheses, you square the first term. 2y times 2y is 4y squared. You change the sign, multiply them together. That would give you 6y. Always put plus, and then you square the last term. 3 times 3 is 9. So a little bit trickier to remember, but once you do a few of them, you'll be just fine. So here, 8 and the z to the 6th are both perfect cubes. The cube root of 8 would be 2. The cube root of z to the 6th would be z squared. So we have 2 plus z squared. Then you square your a. 2 times 2 is 4. You change the sign, so now minus. You multiply them together. 2 times z squared is 2z squared. Always put plus. And then you square the last term. Z squared times z squared would be z to the 4th power. One more of those. Common factor, they have 2x squared in common, which will leave us with x cubed minus 8. Now the cube root of x cubed would be x. The cube root of 8 would be 2. So we have x minus 2. Square a, x squared is x squared. Change the sign, multiply them together. 2 times x is 2x. Put plus, square the last term. 2 times 2 will give you 4. Nice. Is that it? Oh man, I'm almost sad it's over.